In this tutorial, I will be making an FPS controller for a player that walks around a planet, and this is going to be a physics-based approach so that when we're giving input, it's applying force to the player capsule, and otherwise a lot of drag will be applied to bring the player to a halt. So let's get into it. First, I've created a planet which is just a sphere, and I've added these objects around the surface of the sphere just to add some interest to it, and we'll be able to jump up on these things and test out the physics of our controller. Okay, I put a big sphere or a big cube right in the middle, so that makes these corners jut out, and I think that's pretty cool. It'll be like pyramids on the planet. You can see in my folder system down in the project window, I like to create my folders that I'm going to access a lot and have those with underscores at the beginning of the names because that keeps them at the top of the project window when everything is sorted here alphabetically. So the first thing we're going to do after having made the planet is making a player, which is just a capsule. Okay, by default, the capsule comes with a collider, and we're definitely going to want to add a rigid body component, and that way we can apply force to the rigid body. A rigid body also can give gravity and angular drag and rotational force like torque. We're not going to be using Unity's gravity because we need the gravity to be programmed to the center of the planet. So just uncheck this box and bring the player up out of the planet. It doesn't really matter too much where he is because he's going to fall down to the planet when we play. So the first thing I can think to do is just get some simple WASD controls, and the way I'll do that is create a C# script. Let's call it player movement, and open up that script in your IDE of choice. Yeah, that was some code I had previously before when I was just testing out this idea. So first, we're just going to think about how to get the input, which is going to be input.getAxis, and we're going to be getting the horizontal and the vertical axes. This gets the WASD keys. I believe it also gets the arrow keys, and if you have an Xbox controller plugged in, that will get the joystick on the horizontal and the vertical direction of the left joystick, I believe. You can also double check all of that or tweak any of that if you go here to Edit, Project Settings, and Input. You can really refine what kind of input you're working with. Now, if there's horizontal input, we're going to apply a force along the right vector of the player. So if you highlight your player, this is the forward vector, this is the right vector, and this is the up vector. And just, if you're new to vector math, think of a vector as simply a direction without a starting point, or it's not like really tied to any location. A vector is just simply a direction, and it's also a magnitude, like how long of a direction. Anyways, your forward, right, and up axes are always going to be a magnitude of 1. Now, we're going to need to access the rigid body on the player in order to apply a force to it. So I make this private variable called RB because we'll be accessing it a lot. I just like to grab that component one time when I start up. And that's a good practice for any component where you're repeatedly going to operate on it in the update loop. Just do it like this. go ahead and get component, and the component that you want is rigid body, so it goes in the angle brackets. Now we always have the rigid body component in the variable RB. So RB has a method add force. Okay, you can look at the parameters it needs there in the autocomplete. It said it needed a vector 3 of the direction, and the direction is going to be, as I said before, the transform dot right. And you can always multiply a vector by a scalar. A scalar is a number, like think float or integer or even long. So anytime you multiply a vector by a scalar, it's like you're changing the magnitude. Like if you multiply a vector by 0.5, that makes the vector half as long. And also, this kind of multiplication, it is multiplicative, meaning it doesn't matter the order. You can have scalar times vector or vector times scalar. Oops, this should be add force. Okay, quickly check that out. Now, since we turned off gravity, we're not going to fall down or anything. We're just checking out that WASD actually moves us around. For some reason, I guess I took out the game camera. So let me go ahead and put a camera back in. You probably already have a main camera. For now, I just want the camera to be looking at the objects in third person. We'll make that for first person in a little bit. Oh, it is playing. I was waiting for it to load. Yeah, so it looks like the player is just barely moving. We'll want him to move a lot more, so add in a public variable for move force. And this is a float. Now in the inspector, if we go to the script on this player, oh, maybe he wasn't moving at all because I didn't add this. Now the script is actually on it. And now we also have this move force that we can give a value to. This will probably accelerate him into infinity. Or, well, no, he's limited by, okay, limited by 0 drag. I'm going to give him 1.5 drag. Okay, and as I was saying at the beginning of this tutorial, I want the drag to increase pretty quickly once the input stops coming in, and I'm going to do that with an animation curve. So go ahead and create in the project window animation and call it drag. Now, if you don't have your animation window, go to Window, Animator. Wait, that would be this window. To get this window, okay, I'm not going to waste too much of the tutorial. You might have to look that up if you're not getting it, or maybe it'll come up when you do this next step. And that next step is to drag onto capsule. So now with capsule selected, this add property button is no longer grayed out. What this means is you can say our animation curve is going to control a specific variable coming from the object we just dragged it on, and we're going to control the rigid body drag. Okay, now go over to curves. So here is our curve. It's just a flat line along the value of 1.5 because that's the value that was already here. Now I want this to be a 15 frame animation where the drag ramps up pretty quickly, kind of in this sort of shape. This preview, I think that's something I needed. Enable, disable, scene preview mode. I believe I want that clicked. I'll go ahead and add an event at 0 frames and add an event at 15 frames. Drag that far right, what is that, keyframe, over to the 15 frames and put it at the value you need. In our case, I'm going to ramp it way up to 4. We want quite a lot of drag. I'm also going to add another keyframe. Just click up here to move the timeline thing, the white line, wherever you want a keyframe. Click this button. Now we can use this to really drastically ramp up the value. You can even move it in the time direction wherever you want it. Try to make this a little bit better to look at by scrolling with control and the scroll wheel, or also scroll wheel without control does a different type of scrolling. Okay, this should be pretty good. So normally when we're walking around, we have a drag of 1.5, and then it very quickly ramps up to bring the player to a halt. And the drag will sit at a value of 4.0. Now, you'll also want loop time to be unchecked. If you select drag down in your project window, this will ensure that the animation isn't repeating every 15 frames. Now, time to go back into the player movement script. Okay, how am I going to do this? I think we're going to want a boolean for whether the player is basically walking. So that boolean is false, and if there's horizontal input or if there's vertical input, then walking will be true. Okay, since we're only using the WASD keys for this scenario, we can just check if it's equal to 0. If it's, the get axis ranges from -1 to +1, so on a joystick, you may want to check whether the value is really close to 0 to try to simulate a kind of dead zone on the joystick, but with the keyboard, you can just check if it's exactly 0 to get whether there's no input. We're still going to apply force like we were before, just put that in the if statements. Now here, we can check if walking, then we're going to, let's see. Oh, if walking is false, right, then we want to play the animation on the drag. Okay, I need to bring in the animation. So that will be private animator, also call it animator. I like to call my private variables with lowercase and my public with uppercase. It's just a good naming convention to keep yourself straight. And in the start method, we can say animator equals get component animator, just like we did with rigid body. And this way we're not repeatedly getting components over and over in our update loop. So back down here we have animator dot what's it going to be? Sorry, I'm looking over here on my second monitor to remind myself. Oh yeah, play. And you can also look through these autocompletes to see all the methods available. The one I'm looking for is play. And you pass in a string for the name of the animation. In our case, we named it drag. Okay, I think that's pretty good. So I think this is going to repeatedly play the animation as long as there's no input. So let me add in another Boolean to take care of that, which is going to be animating. I'll make that a private bool up here. You can also set variables out at this scope. It's just my coding style to initialize everything in the start. And if you need it to initialize even before that, you can do it in awake. And doing it in awake is the same as initializing it at this scope. So here we can pretty much, we'll just always say animating is false when we're walking. And then here we'll check if animating is false, then we can play the animation. That makes sense to me. Okay. Shoot. We also need to set animating to true. That way, yeah, everything should get reset by the next time you walk and you stop. Let's move all of this code into one method. I just like to keep it clean, keep everything into little pieces. You don't want monster methods. This can just be a private method, actually. Handle walking. And it is void. It doesn't return anything. And the update calls handle walking. Okay, I probably want a... Oh, I did move force. I want the move force to be applied here. So we'll be able to tweak that in the inspector because we made it public. Which, let's go ahead and do that now. Move force of 5. Go ahead and play. Animation event has no function name specified. Very well. Let's go figure out what that is about. rather than waste time there, I'm going to Google that. In the animation editor, you must have clicked the add event. Just right click and select delete animation event. Okay, I guess we don't want these. Let's see if it runs. Yes, it does. And I do not think WASD is actually moving the character. Let's figure that out. Does the character have the script? Yes. Handle walking is being called. If the input is not 0, that must be the problem. Okay, now there's movement. And we're not expecting the character to fall down yet. We haven't done gravity and rotations or anything like that. Next up, yes, I do have my scripts that I previously worked on, so I know what the heck I'm talking about here. Let's do jumping. So that will be another private method. If input get key down, key code space. If the spacebar is pressed, we're going to add a force. A force takes a vector 3, that's the direction and magnitude of the force, which is going to be the transform dot up, probably multiplied by some scalar value that we can tweak in the editor. Let's go ahead and make that variable jump force and add it to the top. Very good. Now here's jump force. We can probably make this quite large because it's only applying the force for a single frame. Very good. We also want gravity. And that's just going to simply be adding a force. Now, if you're new to vector math, whenever you subtract vectors, just remember this. Remember to minus from. So I want a vector going to the planet position, and I know that's not accessible yet. We'll go ahead and take care of that. And it's from the player position, which is transform.position. So let's add in the planet, which is a public transform, and drop the planet in via the inspector. So remember, to minus from. That gives you a vector going from the player to the planet, and we also want to multiply it by a scalar, just like the way I've been doing everything else. Capital because naming conventions, and this is a public variable. I'll go with the same force that we're using for movement. Excuse me. We want a method to make the player stand upright. So, well, let's test out what we have so far and just see what's going on. So we have walking with WASD, jumping with spacebar, and gravity towards the planet. Let's check out what we've got. Okay, brutal. So because it's just simply a physics collider, it falls over like that. And we need it to stay upright. Now, the way we're doing that is pretty much forcing a rotation, so it's always standing perfectly upright from the planet, which is a perfectly fine approach since we're making an FPS game. Yeah, you don't need like weird player rotation in respect to the ground going on when you're doing an FPS. Transform rotation. So if you're not familiar with what transform is, that's like a component on the object that stores the position and it stores the rotation. So you can either access those values or set those values. Also, that if you're a beginner to Unity, it's good to know all of this is the same as doing this dot any component or any part of the game object that the script is attached to. But when you don't write this, it just assumes that you're accessing the part of the object that the script is on. So I usually don't write this dot in front of a lot of things. Transform.rotation is equal to, now whenever possible, you want to look up what quaternion you need to use for your specific problem. Quaternions are a lot better than like Euler angles or other means of rotation, because other means of rotation can get gimbal locked. Like when I was testing this scene out before this tutorial, I was using Euler rotations, and when you walk to the bottom of the planet, you got gimbal locked and you couldn't walk away from the bottom spot of the planet. So looking here at these parameters, it takes a from direction and a to direction. So we're going from the current players up to basically the vector going from the planet center to the player. That's the new up rotation that we want to have. So remember, we're going to do to minus from. That's, in this case, to the player from the planet. Awesome. And this is just like a change in rotation. So you also have to multiply by the current rotation, transform.rotation. Okay. Or a fancier way you could do that, you could take this out and just do times equals. This is saying rotation is equal to rotation times this when you do times equals. Now we can do stand up in our update function. I also want to add a physics material to the player because I want the player to be frictionless with the planet. It shouldn't be like he's walking on sandpaper or anything like that. Okay, I know I very rarely access my physics materials, so that's why I didn't give it an underscore, and it's always going to be towards the bottom of my project window. Now go ahead and create a physics material and call this frictionless. A dynamic friction of 0 and a static friction of 0. It also has 0 bounce. That doesn't you don't want bounce in an FPS, I think. That would be kind of weird. You just want the player to press the space bar to jump. So drag your physics material onto your player. I don't see it there. Oh, here's where it goes. It's inside the capsule collider component. It goes to this field right there. Now, okay, let's see if the player is standing upright. Yeah, it looks like the player is standing towards the planet center. There was some weird spinning action going on there, but we can check that out later. Or maybe that would be angular drag on the player. Let's try an insane amount of angular drag. It seems like angular drag maybe affects regular movement. I'm not sure about that. Also, I notice when I'm moving around, I don't see this drag value changing the way that I want it to. So I'm going to check that. Remember, when I'm moving, I want this down to be like at 1.5. And when I stop walking, I want it to ramp up using the animation curve to get to 4. So what could be wrong with that? Ladies and gentlemen, I have figured it out. So, what you need to do, and what's happening is in our animation, it's playing this curve. And this is kind of a bad scale. It's playing this curve, so it ends up at 4 units, and the animation is continuously feeding that value of 4 into the rigid body, even when we're moving. So actually, when you're in your movement code here in player movement handle walking, you need to set the animator, the animation that's called drag, to the frame number 0. So set it to this frame whenever you're walking. And also do that in the vertical axis handling. You'll notice if you compare all the code changes I made, I'm no longer directly setting rigid body.drag. I just have this. So I think the next thing we can do is put the camera on the player so it feels more like a FPS. I will just drag that onto capsule. While I'm there, I'm renaming capsule as player because why not? Zero out the camera. That's going to put it inside of the player, and we can tweak it a little bit further. Also rotations of 0. Good. So it should be towards the top like it's the head. That doesn't look bad, to be honest. I've got a field of view of 60. I like large, like 90-degree field of view, especially in an FPS, so you can see more. And I'll move that forward. Actually, click this for your orthogonal view, or not. That's not going to work very well. That should be pretty decent. Let's see if we can. Yes, we can barely walk. The controls feel a little bit messed up, so basically this needs to be applied to the forward axis, this needs to be applied to the right axis, and we need a lot more movement force, like at least 10 times more. Move force 50. Let's see what that does. Yikes. That's a lot of jittering. Jump force really should have jumped if we have that force at 100. Okay, less gravity. I don't know if that's helping very much. See, our jump is like nothing. That's kind of weird. Gravity force, it's being used right here. Oh, here's the problem. We need to normalize the vector from the planet, or from the player to the planet, because the size of that distance was affecting the amount of gravity. That's definitely not what we want. Let's try this out. I'll make this 5 again. 5 and 5. Not getting very much jump action. Anyways, let's add in handle turning for now. I'll pause the video later and fix out all the gravity stuff. So that's going to be another private method. And basically it's just a rotation along the y-axis. Like you're just moving your mouse left and right, and you rotate along the axis sticking up out of your head. Here's how we get the mouse axis movement along the X. And some kind of a yaw speed would be good. Apparently I still need way less gravity. Are we calling this? Yes, we are. That's odd. Oh, I know the problem. We need to set yaw speed. I'll set it to 2. Yes, that is rotating now. Maybe it's my stand upright code. Interesting. Oh, I need to get rid of that. How are we doing now? Oh, that was it. Wow, what the heck? Wow. So basically, doing a times equal somehow is behaving a little different than just doing all of this times transform.rotation. So this is exactly the way the code needs to be for a stand upright. The next thing that we can do is add a script to the camera to allow the player to pitch the camera up and down. Camera tilt, that sounds fine. We want a pitch speed and the pitch amount, which starts out as 0. Now, pitch is going to increase or decrease based off of the Y movement of the mouse. And we also clamp that because you can only look so far up or down. We'll say to negative 70 degrees and to positive 70 degrees. Then here's where the rotation happens. I know I'm guilty of using Euler angles here, but I tested this out and at least it works. So you'll notice I'm just updating off of the x-axis, and then I keep my same y rotations and my same z rotations. So that's all you need to do to pitch the camera. Drag that into the scripts folder to keep my hierarchy nice and clean. That's the way I like it. It seems the pitching does not work. Let's figure it out. Oh, it's because pitch speed was 0. Change that to 2. I seem to make that mistake a lot. Okay, everything is starting to come together. So I want a lot more jump and more movement speed. Okay, so go to the player. Let's see, what's a good way to do this? First of all, jump force, we can make that like 200, I think. Drag. I think we want higher move force here. Let's try 10, and then to make the controls feel tighter when you're stopping, I'm going to make this animation go to something higher than 4. let's make it go all the way up towards 10. Yeah, that's gonna be awesome. Oh, interestingly, it slows you down in the air because you're not pressing the movement keys. So you would need to program in something to check whether you're in the air or whether you're grounded. Can we jump up on this yet? Yes, we can. Still want more jump though. Oh, well, what's left? We're pretty much walking around and jumping around now. You could add in like a cool skybox off the asset store. That's always fun. Let's check out the skyboxes. Something that has no up or down direction in the skybox would be good. Like a space skybox. Check this. Yeah, I've used this one before. It's all just images, so I'm cool with that. This is another good thing about using the underscore naming convention for your personal projects. So when you get something off the asset store, that asset is going to come in down here, and you're not going to get confused with what you made versus what's an asset. So to apply a skybox, you go to Window, Lighting, Settings. Here's the skybox material. Put one of those in there. That's pretty cool. Or try out another one of them. Yeah, I like this. And we can even do something with the directional light. Make it kind of match what's going on with the skybox. Do a color picker on the directional light. Pick a color out of the skybox. And maybe brighten that color up a bit. Let's see what... Wow, that's pretty cool. Okay. One more thing we can do is turn off the mouse cursor. That we'll do it in the start for player. That should just be cursor visible equals false. I think I've pretty much implemented everything I want to do for just a quick one video tutorial, so I'm going to cut it off here in a second after I run around and have some fun. It looks pretty legit with the skybox. Got some pyramids in space. You still need to add something to check whether the player is on the ground or whether they're in the air. So basically, when you jump up, and if you take your fingers off the movement, you see the drag went way up because we're in the condition that we're not moving, so there's high drag, and then we fall really slowly. But I fall really fast if I've got the movement key down. Let's go to the dark side. Can we get up on this? Ooh, that's cool. Okay, thanks for sticking with it to the end. Hope you learned something new and maybe we're able to follow along.